Okay, in this video we're going to look at the binomial theorem. This will be part one, where I'll lay the foundation for the things that we need to work some of these problems in this lesson and lessons to follow. Let's look at the statement of the theorem. If x and y are real numbers, and for any positive integer n, we have the following. X plus y to the n, that's your binomial. The first term is x and the second term is y. But keep in mind, those are just general terms. It could be you could have a look at something like 2x plus 5 or 2x squared plus y squared. They can change. Okay, so this is just for the statement of the theorem. So the formula goes n over 0, x to the n, n over 1, x to the n minus 1, y, n over 2, x to the n minus 2, y to the second, and so on. So the point here is that every term of the expansion is going to have an x and a y. Okay? Every term of the expansion on the right will have an x and a y, except for the power 0. So on the first term, you don't see the y because the power is 0. Y to the 0 is 1. On the last term, which is n over n, y to the n, you don't see the x because the exponent is 0. X to the 0 is 1. So if you look at the far right, we have this abbreviated in terms of a summation. J equals 0 to n. So this is saying, okay, if you want to follow this, you replace the j by 0 and you get the first term that I have here. Okay, replace the j by 1 and I get the second term. Okay, and so on. Replace the j by n and I would get the last term. Okay, so also notice that the degree of each term is always n. The first term we have x to the n. So the power is n, so the degree is n. The next one, the powers are n minus 1 and 1. Add them up, you get n. The next one, n minus 2 and 2. Add them up, we get n. So each term has a power of n if you add them up, so the degree of the term is n. Now I'm also defining this notation that I have here, n over 0, n over 1. So the general formula n over k is given by n factorial over n minus k factorial. Again, this exclamation is read as a factorial. And so we have n factorial over n minus k factorial times k factorial. And here we have the definition for n factorial. It's n times n minus 1 times n minus 2 times n minus 3 and so forth, all the way down to 1. So basically n factorial is just the product of consecutive integers from 1 to whatever n is. 0 factorial by definition is 1. 1 factorial is 1. Okay, so just to look at a few examples. And let me change this. 2 factorial would be 1 times 2 or 2 times 1. Either way you want to look at that, that's going to give you 2. 3 factorial will give you 1 times 2 times 3, or 3 times 2 times 1, which is 6. 4 factorial, again, is 1 times 2 times 3 times 4. Or 4 times 3 times 2 times 1. Either way, that gives you 24. Okay. 5 factorial, again, it's just the product of consecutive integers from 1 to 5. So 1 times 2 times 3 times 4 times 5, that's 120. Okay, so that's the way it works. You can also use your graphing calculator to compute these, especially if you have large values. Very easy to do it on the calculator, and I might probably look at some of those methods later on probably in the next lesson. I have some other videos though where I go through that also, so you might look at click on the channel name and find some of those videos. Okay, now if I have this notation n over k, so as an example, okay, let's suppose I have 5, 3. So here the n would be 5 and the k would be 3. So if I look at this formula here, and do it manually without using the calculator, then according to the formula on the numerator I should have n factorial. In this case n is 5, so that should be 5 factorial. On the bottom I should have n minus k factorial. Okay, well in this case it's be 5 minus 3, that's 2, so that would be 2 factorial. And that's times k factorial, but k is 3, so this will be 3 factorial. Okay, and you don't want to say 2 times 3 and get 6 factorial. It doesn't work that way, so you have to compute this out. So 2 factorial we saw was 2, and 3 factorial was 6, and over here we saw 5 factorial, and I forgot my symbol here, this is 5 factorial here, 5 factorial. Okay, 5 factorial was 120. So 120 divided by 2 times 6, that's 12. That's 120 divided by 12, so this is 10. Okay, so that's the way you would use the formula. So now, let's look at some examples of expansions here. So notice then, x plus y to the 0, of course, is 1. X plus y to the first is x plus y. X plus y to the second, if you multiply that out, x plus y times x plus y, using any method you want, you get x squared plus 2xy plus y squared. And x plus y to the third, if you multiply that out again, x plus y times x plus y times x plus y, you get this expansion here. Using whatever method you want, distributive property, and so forth, you get this answer. Now the things I want you to notice, some of these I pointed out as I was looking at the binomial theorem, and that's this: if the power on the binomial is n, the number of terms on the right is 1 more than that. So notice the power here is 0, and I have 1 term, that's 1. On the next one, the power is 1, and I have 2 terms, x and y, 1 more than 1. The next one I have a power of 2, I have 3 terms, 1 more than the power. X plus y to the third, I have 4 terms on the right side of the expansion. I already pointed out again that the degree of each term is always the whatever the power is. So in this one, if I look at the x plus y squared, the expansion, I get x squared. Okay, the degree is 2. xy, powers on the x and the y are 1 and 1. 1 and 1 is 2. And of course y squared is 2. Okay. And then I pointed out that, look at the last one, the first term is always the first term of the binomial, which in this case is x, to whatever the power is 3. And the last term is the second term of the binomial to that power, y to the third. And then to get the other terms, the power on the x decreases by 1 as we go from left to right, and the power on the y increases. So here I start off then with x to the third, and the next one has x squared, x to the first, and then the last term is x to the 0. That's why you don't see it. And then the first term has a y to the 0. Okay, that's 1. And then it goes y to the first, y to the second, y to the third. Okay. Now, using this procedure then, if I wanted to look and say, okay, well, what about x plus y to the fourth? Instead of multiplying this out the long way and say, okay, I got to find x plus y times x plus y, and of course I would get x squared plus 2xy plus y squared. And then if I multiply that again by x plus y, then I would get the last answer that I have over here for x plus y to the third. And then multiply by another factor of x plus y and combine my terms, I'd get the answer I want. Okay, but using what I went through, using the ideas I just discussed, I know that the first term of the expansion should be the first term of the binomial to whatever the power is, which is 4, x to the fourth. I know the last term over here is going to be y to the fourth. So to get the other terms then, I simply decrease the power on the x, so this should be x to the third, and increase the power of the y. Remember, this is y to the 0 here, so this will be y to the first. I don't have to put the 1 there, it's understood, but it's y to the first. Okay, and then plus the next term then, decrease the power on the x by 1. This should be x squared increase the power on the y. Let me fix this. So this should be y to the second. Decrease the power on the y, on the x, I'm sorry, again. So this will be x. Increase the power on the y. This will be y to the third. And then finally, decrease the power on the x by 1. That'll be x to the 0, that's 1. And increase the power on the y by 1. This will be y to the fourth. Okay, there you have it. All I need now is the coefficients. Okay, so if I apply the binomial expansion, then the coefficient of the x to the fourth term should be, and it's 4. So look at the setup over here on the binomial expansion. It should be 4, select 0. Okay, and that's what this formula does actually. Later on, we use this formula to find the number of combinations of n things taken k at a time. It's also used in probability, but this is 4, 0. Okay, so if I expand this using the formula, this is n and k, so this should be 4 factorial divided by 4. Just follow the formula. 4 minus 0 factorial divided by, or times, the k factorial, but k is 0, so this would be 0 factorial. But remember, 4 factorial and 4 factorial, those cancel out. That's 24 over 24. Those cancel. 0 factorial is 1, so the coefficient here is just 1. So this is a 1 right there. Okay. Now, let's do the next one. The next one should be 4, select 1. Okay, if you look at your formula, 4, select 1. So I'll write it over here, 4, select 1. So that's going to be 4 factorial over 4 minus 1 factorial. So this would be 3 factorial. Okay. And this would be 1 factorial. Okay. So 4 factorial is 24, 3 factorial is 6, 1 factorial is 1, so it'd be 6 into 24 will give us 4. This will be 4. So this coefficient right here would be 4. Okay. Now the next one is going to be 4. Let me do it over here. Select 2. So this will be then, if I apply the formula, 4 factorial divided by 4 minus 2 factorial, so it'll be 2 factorial times k factorial, but k factorial is 2, so this will be 2 factorial. So it's 4 factorial is 24, and a 2 factorial is 2, so it's 2 times 2 is 4, 4 and 2, 24 is 6. So the coefficient over here is going to give us 6. Okay. And then the next one is 4, select 3. 4, select 3. So doing the same thing, you'll get this to be 4. Just follow the same thing I've been doing, do the formula. And then the last one, this would be n and n. So in this case, it's 4 and 4. So you're going to have 4 factorial divided by 0 factorial times 4 factorial, but that's 1. So we get the expansion then, x to the 4th plus 4x to the 3rd y plus 6x squared y squared plus 4xy to the 3rd plus y to the 4th. And that's the way you would expand it using the binomial theorem. Now I want to show you this technique also that you can use for these types of problems. We know the first term is always the first term of the binomial to the power. So in this case, x to the 4th. The last term is the second term of the binomial to that power, which is in this case 4, so it's y to the 4th. And you can get the other terms by doing this. Okay, start off with the first term of the expansion. In this case, the exponent is 4. It's 4 times 1 is 4. Divide by the position of that term. That's the first term, so that's 1. 4 divided by 1 is 4, and there's the 4 right there. And then just keep doing that. It's always the power in the first term, so now here, 3 times 4 is 12. Divide by the position of that term, which is 2. 12 divided by 2 is 6. There it is. Okay, continue. 2 times 6 is 12 divided by the position of that term. That's 3. 12 divided by 3 is 4. See, and I get the next coefficient of the next term. Again, 1 times 4 is 4 divided by the position of that term, which is 4. And I get 4 divided by 4 is 1. That gives me the expansion. Okay, that will also work. And you don't have to go through these formula here using the combinations. But the one thing I want you to keep in mind again is this will apply for any binomial. Just keep in mind that the terms are not always going to be x and y. You could have the first term being 2x to the 3rd and say the second term being just a number like 3 or 3y to the 3rd. So the only thing it is where you have the x's and the y's in this expansion, you would have that term in parentheses, and then you just follow the procedure and it's going to work. Now in the next video I'll continue with this using the formulas, expanding, and so one of the things that they'll ask you for these types of problems, they'll give you a binomial taken to a power, and they'll ask you to find a specific term of the binomial, maybe the 5th term or the 6th term, but not the whole expansion. So we'll look at that in the next video. In the meantime, if you have any suggestions or questions, please post them. And also please subscribe to the channel if this is helping you, and we'll see you in the next video.